When dealing with RS-232 communication in an industrial environment alongside frequency inverters, noise can be a significant problem. Here are several techniques to mitigate noise and ensure reliable data transfer. Firstly, shielded communication cables are crucial. Use shielded twisted pair cables specifically designed for RS-232 applications. A cable like Belden 9463 is a good example. Ensure that the shield is properly grounded at both ends to prevent electromagnetic interference or EMI. Secondly, establish a proper grounding system for all devices in the rack, including the programmable logic controller, computer, and frequency inverters. Connect all devices to a common ground point using low-impedance grounding cables. Avoid daisy-chaining devices for grounding purposes, as this can create ground loops and increase noise. Thirdly, consider using isolation devices. Optocouplers or fiber optic converters can electrically isolate the RS-232 circuits from the noisy environment of the frequency inverters. These devices block EMI from propagating between the communicating devices. Fourthly, install surge protectors or transient voltage suppressors on the RS-232 lines to protect against voltage spikes. This can mitigate noise caused by switching events or external electrical disturbances. Fifthly, cable routing is essential. Avoid routing RS-232 cables near sources of EMI, such as frequency inverters, motors, and transformers. Keep the cables away from sources of heat and vibration, as these can degrade signal quality. Sixthly, use filtering techniques to reduce noise in the RS-232 signals. Consider implementing low-pass filters using resistors and capacitors to block high-frequency noise. You can calculate the appropriate values for the resistors and capacitors based on the expected noise frequency. Seventhly, ensure that the RS-232 lines are properly terminated with resistors to match the impedance of the transmission line. This prevents signal reflections and improves signal quality. A typical termination resistor value is 120 ohms, but consult the device documentation for the correct value. Eighthly, adjust the communication settings in the programmable logic controller and computer to optimize performance. Set appropriate baud rates, parity, and stop bits to minimize data errors. Low baud rates can be more tolerant of noise, but may reduce data throughput. Ninthly, consider using communication protocols that are designed to tolerate noise, such as Modbus RTU or CAN bus. These protocols incorporate error detection and correction mechanisms to enhance reliability. Modbus RTU, for example, uses cyclic redundancy check or CRC to detect errors in the transmitted data. Tenthly, periodic maintenance is important. Regularly inspect and clean all RS-232 connections and cables. Tighten loose connections and replace any damaged components. Check the grounding connections to ensure they are secure and free of corrosion. These steps collectively contribute to minimizing noise and ensuring reliable RS-232 communication in your industrial setup. Additionally, you might consider the following to further enhance noise immunity. When using shielded cables, ensure the shield has good conductivity and is not damaged. A compromised shield is less effective at blocking EMI. Use connectors with metal housings that can be grounded to the shield, providing a continuous conductive path. Verify the grounding system's integrity regularly. Use a ground impedance tester to measure the resistance between different ground points. The resistance should be as low as possible, ideally less than 1 ohm. Implement a star grounding topology where all devices are connected to a single central ground point. This minimizes ground loops compared to a daisy chain configuration. When using optocouplers, select devices with high common mode rejection ratios or CMRR. CMRR indicates the device's ability to reject common mode noise, which is noise present on both signal lines. Fiber optic converters are particularly effective at isolating devices because they use light to transmit data, making them immune to electrical noise. Ensure the fiber optic cables are not bent excessively, as this can degrade signal quality. When installing surge protectors, choose devices with appropriate voltage and current ratings for the RS-232 lines. The surge protector should have a low clamping voltage to effectively suppress voltage spikes. Ensure the surge protector is properly grounded for optimal performance. When routing cables, maintain a separation distance of at least 1 foot between RS-232 cables and power cables or other sources of EMI. Use cable trays or conduits to physically separate different types of cables. When implementing low-pass filters, select resistor and capacitor values that provide adequate attenuation of high-frequency noise without significantly affecting the desired signal frequencies. Use a spectrum analyzer to identify the frequencies of the noise present in the RS-232 signals. When terminating RS-232 lines, use precision resistors with a tolerance of 1% or better to ensure accurate impedance matching. Check the voltage levels on the RS-232 lines using an oscilloscope to verify that they are within the specified range. Incorrect voltage levels can indicate signal degradation or noise interference. When adjusting communication settings, experiment with different baud rates to find the optimal balance between data throughput and noise immunity. Use error detection and correction techniques such as parity checking or checksums to detect incorrect data errors caused by noise. When using Modbus RTU, configure the master and slave devices with the same communication parameters, including baud rate, parity, and stop bits. Verify the cyclic redundancy check or CRC values to ensure data integrity. Regularly inspect the RS-232 connectors for bent or broken pins. Use contact cleaner to remove any dirt or corrosion from the connector contact. Consider using a line driver or repeater to boost the RS-232 signal strength over long distances or in noisy environments. Line drivers amplify the signal and compensate for signal loss due to cable impedance. Document all grounding connections, cable routing, and filter configurations for future reference. Keep a record of the communication settings used in the programmable logic controller and computer. Implement a preventative maintenance schedule to regularly inspect and test the RS-232 communication system. This helps identify and address potential problems before they cause downtime or data loss. Consider using a data logger to monitor the RS-232 communication for errors or anomalies. Analyze the logged data to identify patterns or trends that may indicate a noise problem. Consult with an experienced electrical engineer or technician for assistance in troubleshooting complex noise problems. They can use specialized equipment and techniques to identify and mitigate noise sources. Implement a training program for personnel who work with the RS-232 communication system. Ensure they understand the principles of noise reduction and the importance of proper grounding and cable routing. By implementing these additional measures, you can further minimize noise and enhance the reliability of your RS-232 communication system in the industrial environment. Always adhere to relevant safety standards and regulations when working with electrical equipment. Ensure all devices are properly grounded and that appropriate personal protective equipment or PPE is used. Regular monitoring and maintenance are key to ensuring long-term reliability and performance of the RS-232 communication system. Consider implementing a redundant communication system as a backup in case of failure. This can help minimize downtime and ensure continuous operation of critical equipment. Consider using industrial-grade RS-232 converters and isolators that are designed to withstand harsh environmental conditions. These devices are typically more robust and reliable than commercial-grade components. Implement a robust configuration management system to track all changes to the RS-232 communication system. This helps ensure that the system is properly configured and that any changes are documented and tested. Consider using virtual serial ports to simplify the configuration and management of RS-232 devices. Virtual serial ports allow you to create software-based serial ports that can be accessed by applications. Use a serial port analyzer to monitor the RS-232 communication and identify any errors or anomalies. Serial port analyzers can capture and decode the RS-232 data, allowing you to troubleshoot communication problems. Implement a data validation process to ensure that the data received over the RS-232 communication is accurate and complete. Data validation can include checksums, parity checks, and other error detection techniques. Consider using a real-time operating system or RTOS and the programmable logic controller to improve the reliability and performance of the RS-232 communication. RTOS provides deterministic timing and can help prevent data loss or corruption. Implement a robust security system to protect the RS-232 communication from unauthorized access or modification. Security measures can include encryption, authentication, and access control. Consider using a wireless RS-232 adapter to eliminate the need for physical cables. Wireless RS-232 adapters use radio frequency or RF technology to transmit data wirelessly. Implement a comprehensive testing and validation plan to ensure that the RS-232 communication system meets all requirements. Testing should include functional testing, performance testing, and security testing. Consider using a simulation tool to model the RS-232 communication system and identify potential problems. Simulation tools can help you optimize the system configuration and performance. Implement a continuous improvement process to identify and address any weaknesses in the RS-232 communication system. Continuous improvement can involve regular audits, performance monitoring, and root cause analysis. By implementing these advanced techniques, you can achieve a highly reliable and robust RS-232 communication system that can withstand the challenges of the industrial environment. Remember to always consult with qualified professionals and adhere to relevant safety standards and regulations. Also, when dealing with frequency inverters, harmonics can be a significant source of noise. Consider using harmonic filters to reduce the harmonic content in the electrical system. Harmonics can cause interference with sensitive electronic equipment and can also damage electrical components. Ensure that the frequency inverters are properly grounded and shielded to minimize the emission of electromagnetic interference. Use line reactors or chokes to reduce the switching noise generated by the frequency inverters. Line reactors can help to smooth the current waveform and reduce voltage spikes. Consider using sine wave filters to reduce the high-frequency noise generated by the frequency inverters. Sine wave filters can help to improve the power quality and reduce the electromagnetic interference. Implement a power quality monitoring system to track the voltage, current, and harmonic levels in the electrical system. Power quality monitoring can help you identify and address power quality problems before they cause equipment damage or downtime. Consider using an uninterruptible power supply or UPS to protect the RS-232 communication system from power outages and voltage fluctuations. UPS can provide backup power and can also filter out noise and voltage spikes. Implement a remote monitoring and control system to allow you to monitor and control the RS-232 communication system from a remote location. Remote monitoring and control can help you to quickly diagnose and resolve problems. Consider using a cloud-based platform to store and analyze the data collected from the RS-232 communication system. Cloud-based platforms can provide scalable storage, powerful analytics, and secure access. Implement a disaster recovery plan to ensure that the RS-232 communication system can be quickly restored in the event of a disaster. Disaster recovery planning should include data backups, system recovery procedures, and communication plans. Consider using a virtual private network or VPN to secure the remote access to the RS-232 communication system. VPN encrypts the data transmitted over the internet and protects it from unauthorized access. Implement a multi-factor authentication or MFA to protect the RS-232 communication system from unauthorized access. MFA requires users to provide multiple forms of authentication, such as a password and a security code. Consider using a security information and event management or SIEM system to monitor the RS-232 communication system for security threats. SIEM systems can collect and analyze security logs from various devices and can help you to detect and respond to security incidents. Implement a vulnerability management program to regularly scan the RS-232 communication system for vulnerabilities. Vulnerability scanning can help you to identify and remediate security weaknesses. Consider using a penetration testing service to simulate a real-world attack on the RS-232 communication system. Penetration testing can help you to identify and address security flaws before they are exploited by attackers. Implement a security awareness training program to educate employees about the importance of security and how to protect the RS-232 communication system from threats. Security awareness training can help to reduce the risk of human error and social engineering attacks. By implementing these advanced security measures, you can protect the RS-232 communications system from cyber attacks and ensure the confidentiality, integrity, and availability of the data. Remember to always stay up to date on the latest security threats and vulnerabilities and to implement appropriate security controls to mitigate the risks. Proper planning, design, implementation, and maintenance are essential for a reliable and secure RS-232 communication system.